All right, welcome everyone. We're going to be talking about Docker today. As a reminder, this is the room for Docker. If you want to be in the Python visualization room, you want to be in the auditorium. And as usual, we won't be offended if you change your mind partway through. All right, so before I jump too far into actually using Docker, I'm going to start by saying this is the one lesson we give that we can't do on the hub because we can't run Docker in the Jupyter hub. So if you didn't notice in the general channel and the Docker lesson channel, there's instructions for how to install Docker. If you have not done that yet, you should go do it right now. And I'm going to talk a little bit about Docker right now before I jump into things, and that's your time to get it installed. So it's in the, if you go to the Benson Docker channel, it's pinned in there. It's also in the general channel from earlier in Slack. So you may have to join the channel. Yeah, it's also in the general channel. If you scroll up a little bit, there's a message. But real quick, I can also just show you, just go to docker.com. There's a get started button. You can go over here and click whichever one you, well, I guess I'm downloading that one. You can click whatever processor you need to download Docker for. It's an install program. Docker is a big piece of corporate software, so it's not like a lot of the stuff we use where you have to install it yourself using, you know, whatever package manager. It's a program that will install itself. Yeah, if you haven't done that, run it now. If you're on Windows, you will also need access to a terminal. You'll need access to a terminal no matter what, but if you're on Linux or Mac, that will come with your operating system. If you're on Windows and you don't know how to open a terminal, you can install Git Bash based on some instructions also in that channel. Hopefully you have time to do that while I talk about Docker. All right. Unfortunately, if you can't get Docker installed for some reason, for example, if you don't have administrative access on your machine, there's not a whole lot I can do to help you. You'll just have to review this later and go along with them. Okay. Also in the channel, I've posted a link, this link right here. This is actually posted on, if you were in this room yesterday, Adam gave the lecture. He's actually the one hosting this on his GitHub pages. And the reason for that is because we have rewritten the software carpentry Docker lessons to be a little bit more up to date. And this is the lesson. It's very similar to software carpentries, but this is the lesson we'll be using today. Okay. So Docker itself is a really interesting piece of software. It came about because there's a common problem we face, and not just us as scientists, but people in industry all the time, which is that we've written some piece of software. We can run it on our computer, or I can run my software on my computer. But it works on my computer because I have the right version of Python installed, and I have the right version of NumPy installed, and I have all the appropriate Fortran libraries that NumPy works with, and I have all that kind of stuff set up in a way where my system can find all those libraries and those bits and pieces. If I then take just the Python code that I've written and I give it to you, and I just email it to you, for example, and you open it up and try to run it, it's going to say, well, I don't have this particular library that I need installed, and so everything's going to fail. If you happen to have the right setup on your computer, then great, it'll run, but that's a big if. And in particular, if I'm running on a Linux computer and I give you software and you're running a Windows computer, there's a really big chance that it's not going to work. So there's long been a concept of virtual machines in computing, the idea that we want to set up a sort of mini computer in the software of another computer in order to try to simulate that environment that I gave you the code from. So the idea would be I would give you this Python code, and then you would set up some virtual machine that ran Linux, and you would set it up the way that my machine was set up, and then you would run that Python code inside the virtual machine. Docker is a tool for making these kinds of virtual machines. And by the way, before I forget, people on Zoom, I can't really monitor the Slack or the Zoom chat, so if you have a question, please just shout out. We can't hear you. If anyone sees Zoom people asking questions in the Slack, please let me know. Right. So Docker is a tool for managing virtual machines, and it basically takes the idea of virtual machines and pretty much turns them into little packages. So there's something called Docker Hub, which we'll talk about in a little bit here. Docker Hub is kind of like GitHub for Docker images. The idea is that people will make their own Docker images. I've made my own Docker images and put them on Docker Hub, and you can basically just tell Docker to go pull those images down and set up a virtual machine, and it's very easy. It's just in the command line. I'll also just mention briefly that Docker was not originally designed, at least as far as I know, for scientific software. It's just very useful for it. It was originally designed, I believe, for people in industry who wanted to provision large numbers of identical compute instances for like web pages that need to run have lots and lots of clients. And in particular, it was made for when a web page maybe has a lot of traffic during certain times of the year and not other times of the year. And so sometimes they need to spin up hundreds of instances to handle all the traffic, and sometimes they just need a couple. And the idea is that Docker makes it very easy to just start up an Amazon EC2 instance in the cloud and say, hey, pull this Docker image and run it. Since that Docker is a virtual machine, it'll run the same way every time, no matter what compute architecture you're running Docker on. That's the basic idea. Okay, before I jump into the command line or anything, and since I want to give everyone just a little more time to install Docker, any questions so far? Yeah.
What are the most common use cases for Docker?
Yeah, great question. So I think the most common use case is the one I just described in the cloud, with like where corporations need to run it for web services. Setting that aside and just thinking about science, in my experience, there's a couple use cases. One is that you've got some kind of web server that you want to run that's part of a scientific tooling. So, for example, you might have some tool that like manages a lab's subject data set or something, and you might package the web server for that tool inside a Docker image. You see that sometimes. What I've used it for is I'm publishing a paper, and I did a bunch of computation for that paper. And I want to make sure that anyone else can run those computations without necessarily having my exact compute environment installed. So I publish those computations in a Docker image, and you can actually take a Docker image, have Docker spit it out into a tar file, and then you can put that on Zenodo where it gives you a DOI. This is all kind of discussed in the lessons. I don't know that we're going to get into this today, but that's the basic idea. Yeah.
Someone on Zoom said that Zoom hasn't started yet.
Zoom hasn't started yet. It should be recording already. Is that what they mean? Zoom people, can you see my screen?
Yes, and it looks like it's recording.
Okay. Right. Well, if someone has clarification as to what's not started, I'm happy to fix it. But all right. Any other questions? Yeah.
Is Docker open source or
Oh, that's a great question. I believe it's closed source. I don't think you can go get the Docker source code. I think there's a company that maintains it, but it is very common. It's very standard. Yeah.
Are you going to talk at all about Singularity?
I'm not, because I've never used Singularity. However, well, here's what I'll say about it. So Docker is a tool that has particular use cases in mind. One of those use cases was not running on a high performance compute center where you want to run like a lot of jobs. And even though that seems like a very natural use case to us because we use those kinds of high performance compute centers a lot, it wasn't something that the people who wrote Docker were thinking of. So Docker requires administrative privileges to run. That's just how it's been designed. And as a result, you can almost never run it in a high performance compute cluster because you almost never have administrative privileges. Singularity is supposed to be able to take Docker images and turn them into Singularity images, and then those can run as a single user without administrative privileges. I know people who have had really good luck with that. I have never done it myself, so I can't talk about it very much. But yeah, if that's something you find that you'll need to do, and I totally agree that virtual machines and containerization is a great way to run high performance compute cluster jobs. If that's something you'll need to do, look into Singularity. Yeah, it's supposed to be very easy to take a Docker image and make it a Singularity image. Yeah. Okay, any other questions? All right. So the first thing before we actually jump into Docker, we need to make sure Docker is running. If you are on a Mac, you should see something. If your Docker daemon is running, you should see something like this little icon up here. Maybe a little hard to see, but it's basically looks kind of like a whale with a bunch of crates on top of them. Mine has an exclamation mark in front of it, I think because there's some message I've ignored. But regardless, you should see something like that. If you don't see something like that, just go search for Docker and run that, and it'll take a minute to start up. Oops. It'll take a minute to start up, but and you'll see this little icon like crates appearing and disappearing while it starts up. But basically, once that icon is like up there and stable, Docker is running. Okay. On Windows, I think the icon appears down in the lower right. I haven't used Windows in like 20 years, so I'm not totally sure, but okay. All right, so once Docker has started, we can just test. First of all, we'll just test that you've got Docker installed. We're just going to run this docker-v for version, and you should get something like this. It should print Docker version, blah, blah, blah. It may not be exactly the same version as mine, and that's fine. If anyone had that fail, that probably means Docker is not installed. You should go try to install it from docker.com. Okay. So I mentioned that there's a website called Docker Hub, and you can people can post Docker images there, and you can pull Docker images off of Docker Hub. And that's all built into the Docker command line, and we're just going to start by using that. So we're going to say Docker pull, kind of like git pull, hello world. So of course there's a Docker hello image for hello world. And basically it's just, it very quickly should pull it. And then we can just say Docker run hello world. And you should get something like this printed out. So this is just a little bit of information about Docker. This is literally made for these kinds of tutorials. Basically, this just tells you kind of what Docker did in order to run this hello world program. And the basic idea is that when we told Docker to pull hello world, it went up to Docker Hub, looked up the Docker image that was called hello world, downloaded all the various pieces of that Docker image. And Docker is very smart about downloading pieces. So if you've already downloaded a piece of an image that's shared between images, it knows not to re-download it. Then it turned that image into what's called a Docker container. So we'll talk a little bit more about this as we go, but there's a bit of vocabulary here. Docker has images and containers. Images are basically like a snapshot of the file system and configuration of a virtual machine. It's not something that's running, it's sort of like instructions for Docker to run a virtual machine. And Docker images exist up in the cloud on Docker Hub, and that's what you pull down. A Docker container is where you take a Docker image and you start running it as a virtual machine. So once it's running on your computer, it's a Docker container. Okay, any questions so far? All right, so let's start looking a little bit more at some of these commands, the Docker command line. So we're going to start with Docker image ls. So kind of like Git, Docker has a bunch of subcommands, and many of them have subcommands. So Docker image is how we interact with Docker images, and ls just is telling it to list the Docker images. And what you should see, now if you've been running Docker before this, you may have other Docker images in this list, but you should see at least the hello world Docker image in that list. So this is telling us that we have locally on our computer, we have the hello world Docker image. All right, another command is Docker container ls. Yeah.
I've got a question about the ls command. So is it showing the images that we pulled or the containers that are running?
So Docker image ls shows us the images that either we've pulled or that we've made. Any images on your computer should show up there. Docker container ls, which is what we're going to do next, will show you the containers. Yeah. Now, when we run Docker container ls, you'll notice that there isn't a hello world container, even though we literally just ran hello world. And that's because we ran it, it printed output, and then it exited, and it was done. And so it's not running anymore, so it's not shown there. I believe if we say Docker container ls-all, it will show us that there's this container here that exited 3 minutes ago. So that's basically saying this is a finished container, and so it doesn't show up unless we tell ls to show us all the containers. Okay, so hello world is just a little example of Docker, and it's a good way to test that you all have Docker installed and working. If you were able to do that, then your Docker installation is fine. If you weren't able to do that, then it probably means either your Docker daemon hasn't started yet, or something else about the installation went wrong. Yeah.
How does it choose like what partition to use and like computational efficiency for like your local machine?
So you mean, how does Docker decide how many like resources to use and what to use as the file system and such?
Yeah.
Yeah, so that's a great question, and is actually a great excuse to show you something. If you go to this Docker daemon, you can open up a dashboard. And there are various, well, they've changed this a little bit. There used to be a settings you could go and change here, and maybe I've just.
I think it's in the top right.
A little bit.
Oh, thank you. They did change that. Okay, it's just a little tiny icon now. All right. Yeah, there's some things you can set here. There's resources. You can tell it how many CPUs it's allowed to use, for example. You can tell it how much memory it's allowed to use, how much swap space, how much disk space. I generally recommend, especially for like scientific computing uses, that you turn your CPUs up and your memory up, because it starts with a very low memory limit. I would turn it up to at least, you know, a significant chunk of what's on your computer. These are handy if you want to be running Docker stuff in the background. But especially if this memory is low, it's very easy to run a Docker image that runs out of memory, or to run a Docker container that runs out of memory. And if that happens, it will just mysteriously die and not give you any real error message, and you'll just be kind of stuck trying to figure it out. So I do recommend turning this memory up. There's other settings in here. A lot of them are for networking settings. I'm not going to dwell on any of these, but this is where you can set a lot of those details. As far as the file system, that's actually a good point. Docker maintains its own sort of, all the images you download, it maintains in its own kind of secret directories. For the most part, you don't interact with them except through the Docker command. Yeah.
Is there like a dashboard that comes up for, let's say, Ubuntu for Linux systems? I'm running it through Ubuntu.
So, I honestly have never run it on Ubuntu, so I'm not sure how it works. There is? Okay.
Yeah, I can paste it in, so.
Okay, thank you. Yeah. Great. Yeah, I assume there must be. I just knowing Ubuntu, it might be more complicated or hard to open. All right. Okay, so we are pretty sure our Docker installation is working. Let's go ahead and do something a little more complicated. So we're going to be using pretty much all the work we're going to be doing today is going to be in a Docker image called Alpine. Alpine is basically a Linux distribution that's been really pared down to be as small as possible. And the reason we do this is not because Alpine is the best image for you to use. It's because Alpine is small, and when you all go and pull this from Docker, I'm not asking Docker to send us like 50 gigabytes worth of data in the next few seconds. If we did that, it would take all of you a very long time to download these images, and we'd just be waiting here until we could start. So we're going to work in Alpine. Now, previously we did Docker pull hello world, and then we did Docker run hello world. You actually don't need to run that pull command. You can if you want to pull something ahead of time, but if you tell Docker to run a container, it'll go and look for that image on Docker Hub and try to download it. So we're just going to start with Docker run Alpine. So notice it says unable to find Alpine locally. Pulling from library Alpine, downloaded newest image or newer image for Alpine latest, and then it looks like it didn't do anything. And that's because Alpine doesn't do anything if you just run it without any arguments. So let's run this again. we'll do Docker run Alpine, and now we're going to give it a command to run. So we're going to use this command cat /etc/os release. So Alpine is a Linux distribution. Yeah.
Sorry, just a quick question. The previous command did it download the image, run the computer, and then roll the computer.
Yes. Yeah. In fact, that's a great point. It did download and run it. So if we say Docker container ls-all, whoops, you can see that Alpine here exited about a minute ago. Yeah. So it did run it. It just didn't do anything when we ran. Okay. So we're going to run Docker run Alpine. We're going to run this command cat etc/os release. On Linux systems, on most Linux systems, /etc/os releases information about the version of the Linux operating system. And the cat function just prints a file to the screen. So this should just print our OS release to the screen. And there we have it. The version of Linux is Alpine. This is the version ID, etc. Okay, so we can run a simple command inside of the container. Let's do a slightly more complicated command. Docker run Alpine sh. So sh is the shell command. I think maybe we have to do /bin/sh. No. Let me check my notes. Oh, of course. I forgot an argument. Docker run -it Alpine sh. So what I forgot here is this -it, and -it says that we want to run this interactively. So basically, if we don't put -it, Docker forks into the background and attempts to run things without any interaction with the keyboard. When we do IT, we can interact with it with the keyboard. Okay, now we are inside of the Docker container. So if I just type cat /etc/os release, you can see the same thing we saw earlier. And what's happening here is that when I ran this, it took the Alpine image, made it a container, started up that virtual machine, and then it ran the sh command, which is the shell command. It's just the bash shell inside of the virtual machine. And that's what this prompt is for. This / just indicates that I'm in the root directory. So for example, I can say ls. You can see all these quintessentially Linux directories here. I could say cd space etc. And now you can see that I'm in the etc directory. Can everyone see this okay?
Yeah.
Okay. Okay. Any questions so far? Okay. So clearly we can start up a Docker image into a Docker container, and we can get a prompt inside and we can interact with it. Let's go ahead and install something. So I believe in Alpine Linux, the command for installing things is apk. I'm just going to say apk-h. Okay, that's correct. It is the tool. I think what we want to install here, let's go ahead and make sure we have Python installed. Okay, so this doesn't seem to have Python installed, so we'll start by installing Python. So we'll say apk install Python 3. Oh.
And that will install Python only in the container, or?
It will install it in the container. I just apparently have the wrong command here. Let me just check my notes. Add, you're right. And in fact, I think it may be add -- install. So obviously I don't use the Alpine distribution for Linux very often. It's really just for these kinds of demos. Okay, I think we just need to say apk add. So this is I believe this is the command for installing things, and we're going to say Python 3 and see if that works. There we go. Okay, so we've now installed Python 3 inside of this running Docker container. And we should now be able to say Python -v Oh, that's Python verbose, not Python version, my mistake, but that's okay, it worked. It started up Python and it showed us a whole bunch of startup messages. And then we get a prompt where we can just make sure it's working. So it seems like everything's fine. I'm gonna go ahead and exit. Okay, so we've installed Python. Now I'm going to go ahead and exit out of this interactive shell, which means it's going to exit out of this this container instance, and that takes me back to my my own computer's prompt. Was everyone able to do all that? Do I need to scroll up or anything? Yeah.
Can files be moved from the container to outside to your system?
That's a great question, and the answer is yes. So let's see. I don't have notes on that, but I'm going to try it anyway. So let's go ahead and say Docker container ls. We'll see that it doesn't list any containers because we exited out of the container, so it's gone. But we can say Docker container ls -- all. And notice that there's now multiple of these, partly because I did all those commands that just failed. So some of these are those. But we can see the hello world still listed here. We can see Alpine, and then there's up to this one, which I just exited about a minute ago at this point. So this particular line, and given this line is wrapping around here, but this particular line has the information about the specific container that I just ran where we installed Python. And I know that because it's the one that exited most recently. So you see there's a container ID here, and then an image. So that's the image, the Docker image that this container came from originally. And then the command that was run, which in our case was sh. Okay, so this container ID can be used to reference the Docker container, even after it's finished running. So I'm just going to copy this, and I'm going to, hopefully this works, but we're going to say Docker copy. I believe the command is copy, and I'm just going to say -- help just to make sure that's right. Yeah. Okay. So you see here it says Docker copy options container source path des path. So just as an example, let's Docker copy. We'll take that particular container ID, which I'll just paste there. I think if you just write like 1A1 or A111A or whatever your version of that is, like you just need to write enough of it to identify it, I think. But I'm going to put a colon after that ID, and I'm going to say /etc/os release. And I'm just going to copy it to the current directory. And now I'm going to cat /os release. And you can see that it copied it out and it's on my computer now. So that's one way you can copy things out of the Docker container. There's also, and I think this is kind of important. If I can remember, I believe it is Docker. Yeah.
What exactly did we copy?
Sorry. So here in the Docker copy command, we had the Docker container ID, and then we put a colon, and then we had the path inside of the Docker file. So, or inside of the Docker container. So this is just a text file that's included in Linux distributions that says the information about the operating system. And this path inside of the Docker container is just that file, and we just copied that out into the current directory. So when I typed cat /os release, that says on my local computer, not inside the Docker container, print this particular file to the screen, and that's what this is. So did that make sense?
Yeah, thank you.
Good, no problem. Yeah.
So it basically takes the ID of the previous command, it reruns that exact same command, and then it just copies whatever's inside into like our local directory, right?
So it doesn't actually rerun anything, because when we ran the Docker container, we installed Python, we shut it down, it kept that around, it didn't delete it when we did that. So when I said Docker copy here, it went back to its record of that container and copied the file out of the container. Does that make sense?
So it means that, if I understand correctly, the Python is still installed in that ID. So where is it So there's a cache or something storing like the history of what happened.
It's not the history of what happened. It is the state of the container when we exited. So it's the way to think about it is it's a virtual machine that sort of lives inside of files that Docker manages. And when we ran the Docker, or when we ran the sh command, it started up the virtual machine and we interacted with it and installed Python. And then when we exited and the Docker finished running, it took the state of the whole virtual machine and wrote it out as like a snapshot on your hard drive somewhere. And when we copied, it went to that snapshot and said, okay, let me go grab the etc/os release file out of that snapshot and copy it out.
So we can, if we potentially like lose some information, but we remember that it's stored like in a container, we can like recover it.
Exactly, yeah. Yep.
Doesn't it take too much space?
Docker can take a lot of space, and I'll show you how to clean it up later. Yeah.
Sorry, just following up on that. You took the container ID of the latest instance of that container. So what if you had taken one of the previous ones? Would that have been a snapshot of the container at that point?
Correct. So let me clarify a little bit. Every time we turn the image into a container and run it. Every time we do a Docker run, it takes the image and makes a new virtual machine. It's a new container. So the first time we did that, it exited and saved a snapshot of that virtual machine. The next time, it's a totally new snapshot it saves because it was a totally new virtual machine it started. So if we now Docker run Alpine again, it won't have Python installed because it's a different container. But the container that we installed Python in will still be on your hard drive with that same ID we just used. Does that make sense?
Okay.
Yeah.
So then we can like refers that snapshot and rerun from method.
Yep. Yeah. So it exists because you may want to restart it. We might want to go back to that Alpine container and get it running again and connect to it again and interact with it more. So in a way, Docker is very flexible about kind of how you start and stop containers. And it's very good at turning images into containers and kind of keeping them around. Yeah. Yeah.
So how do you save progress, like if you're building a container?
Yeah, so that's a great question. There's actually, so I would say, first of all, the best practices way to do this is to have, which we're going to talk about in just a minute, is to have a Docker file, which is basically a set of instructions for how to set up a container. That is what you want to install inside of it and what commands you need to run to get it ready for you to use. And usually what I do is I just rebuild the container from the Docker file, and then it'll be pretty much guaranteed to be the same. So we'll see how to do that in a minute. That said, I know a lot of people, especially people who do development. So some people will put their entire development environment inside of Docker containers and Docker images, and only ever program and test and run things inside of Docker. You can run a Docker and shut it down and then start it back up and reconnect to it. That is all stuff you can do. It's not stuff we're going to talk about today because we have very limited time today, unfortunately, but it is possible. Yeah. Okay. Other questions? Yeah.
Can you erase that version control, like the older instances of the container?
Yes. Yeah. So I'll show you how to do that next, actually. Okay. So this is, I just want to talk about Docker save real quick. This is kind of an important command for scientific computing specifically, because it lets you take the entire image and save it out to disk. Now, unfortunately, this doesn't work for a container. This works for an image, but we'll see why that's important in just a minute. But the basic idea is you can say Docker save, and then we can say Alpine, for example, and we'll say dash. Actually, I think I need to put this here, -o /alpine image .tar Alpine. And this says, take this image, make it into a tar file right here in my directory. And that'll spit it out right there. This is the file you can take and upload to Zenodo, and other people can download it and run it as a Docker image. So we'll come back to this once we've looked at Docker files, but this is a kind of important thing you can do. Okay. At this point, let's since we're already talking about Docker files, let's go ahead and make one. I'm going to go ahead and CD into my desktop. You don't need to do that. That's up to you. And then I'm going to make a directory that's just called Docker lesson and CD into it. You don't have to be in any particular directory, just somewhere to kind of put a Docker file. So typically when you're using a Docker image or Docker containers, you're going to want to have some set of instructions that builds up the Docker container. So we just saw that you can start a container and run some commands to install stuff in it. But ideally, you want the image to kind of be set up ahead of time. So the way that you do this is by using what's called a Docker file. And we're just going to start by using Nano to create a Docker file. Docker files are always named Docker file with a capital D. You can use alternate Docker files, but this is just the standard and people always do it this way. And the Docker command will look for a file named Docker file in your current directory. So we'll go ahead and start that. And I just want to make sure I have my notes here. Okay. So Docker files have their own format. There's almost like a little scripting language. It's a very simple scripting language. You typically start a Docker file with the command from. And from just says, what Docker image do you want this new Docker image we're building to be based on? So in our case, we're going to use Alpine. We already saw Alpine. Basically, what we're saying is we're building a Docker image, start with the Alpine Docker image and run all this stuff inside of it. Okay, so we're going to start with Alpine. The next thing we want to do is we want to make sure that we've installed Python. So we're going to tell it to run the APK command with this run command. So run is very simple. Everything after run is a command, and it just runs it inside the Docker. So we say APK add Python 3. And I'm also going to add py3-pip because we may want to install something with pip. And then finally, we're going to add another line here, which is command, and we're going to have this just be sh. Command is basically it's a line that says, suppose someone comes along and says Docker run your image, and they don't put anything after, like as part of the command line. What should it do? Well, it goes and looks at the command and it runs whatever you've got there, assuming they don't provide any other inputs. So this is sort of a way of saying, for example, you may want to have a Docker image contain a set of scripts that's designed to be run on like a BIDS data set or something like that. That's a pretty common use case. In fact, if you've ever used fMRI prep, they have a great big Docker container where you Docker run and you give it, or you Docker run fMRI prep and you give it inputs that correspond to your subject, and basically the scripts for preprocessing your subject all run inside of the Docker. They tell in the fMRI prep Docker file, they use commands like the command. Sorry, they use lines like this with the command, whatever, I guess it's command, to tell the Docker image to run their particular scripts when you start it up. So that's all this does. Okay, so as a reminder for Nano, if we want to save this, we push Control O. And then say, yes, I want to save this as the file Docker file, and then Control X to get out of here. And just to test that that worked, I've got Docker file there. Okay, so we've made a Docker file. If we want Docker to read that Docker file and run the commands, we run Docker build. And we're going to give it an argument -t, which is for tag. It basically says, what do we want to call this Docker image? And we're going to call it Alpine test. And then finally, we give it the current directory. I'm just going to say dot. In Linux bash, the dot always stands for your current directory. So go ahead and run that. And you'll see it starts doing stuff. And that was pretty quick. It would have started by downloading Alpine if we hadn't already downloaded it, because we said it needed to be based on the Alpine Docker. It then goes through the Docker file, and you can see that it said run here. It's running this command, and eventually it finishes, and that's that. Now we can say Docker image ls, and we can see not only the hello world and the Alpine image, but the Alpine test image that we just created. So now, if we say Docker run -it Alpine test, it goes right into that prompt. We didn't have to put the sh command at the end. We did still have to put this -it because we wanted to have an interactive prompt with the Docker container, but we didn't have to put that sh command because we had that command line that said that to run sh if there wasn't anything provided. Yeah.
Could you specify the
I don't think so, because I think after you put the Docker image, so for people on Zoom, if you couldn't hear it, the question was, can you specify this IT after the Docker image name? I don't think so, because I think it's expecting commands for inside the Docker image at that point. So you have to put the arguments to run right after run and before the Docker name. Yeah. Any other questions? Okay. All right. And let's just verify that Python got installed. We'll say Python -- version. And you can see that Python's already installed inside this Docker image, or this Docker, excuse me, container, because we installed it in the Docker file. Okay, I'm going to go ahead and exit. Now I'll just mention that we called this Alpine test, and you'll notice that the Docker we've been using is called Alpine. Traditionally, Docker images are named username / Docker Docker image name. So, for example, I maintain a library called NeuroHackademy, and the name for that library is Docker image, which basically just contains a fully installed version of NeuroHackademy that anyone can run. And it contains like a Jupyter Hub instance where if you start the library, or if you start the Docker, it'll start up a Jupyter Hub instance that has NeuroHackademy installed in it. The name for that Docker image is nben / NeuroHackademy, not NeuroHackademy, because my username on Docker Hub is nben, and so my Docker images are all nben / whatever. Alpine does not have anything, a username, because it's maintained by the Docker team. Same with Hello World. So any of the kind of core Docker images typically don't have usernames. The same is true for a lot of the Linux distributions. So like typically I would use a Docker image for Ubuntu and not Alpine when I'm installing software and stuff. And that's because Ubuntu is a more kind of fleshed out, complete distribution of Linux. Alpine is a very minimal distribution of Linux. It's great for these demos where we don't want to be pulling a lot of data, but usually we'd use Ubuntu instead. Okay, now it's totally fine to name Docker images whatever you want on your computer. It only really matters if you want to push a Docker image up to Docker Hub. And if you have an image on your local computer, you can actually just, in theory, Docker push, and then whatever the image name is. And if your Docker daemon has been authenticated with Docker, it'll just upload it to Docker Hub. It's very easy. You can have public Docker images for free on Docker Hub. Private ones cost money, I believe. At least last I checked, they've changed that in the past, so hopefully they keep it free. But if we were gonna try to push Alpine test, we would run Docker push Alpine test, and it would upload the Alpine test. However, it would reject it because it doesn't have a username in front, and my Docker's images need to be tagged with my username. Okay, so I'll just delete that. Okay. So let's make a slightly more complex Docker image at this point. I'm going to go ahead and open up our Docker file again. This is all fine so far. However, what we're going to want to do is we're going to install a little Python script that does something very simple inside of our Docker image. And I opened this up, but now I realize I'm just going to exit because we need to write the script first. So I'm going to say nano sum.py. This is just going to be a very simple Python script. All it's going to do is it's going to take a series of integer command line arguments and add them up. So in order to do this, we need to import sys, because sys is where you get your command line arguments. And then we're going to say total equals 0. We're going to add the numbers up into the total. And then we're going to say for arg in sys.arg. I believe it's argv. Anyone know that offhand? I think it's argv. In sys.argv, we're going to find out if that's correct in a second. If in sys.argv, the first argument 0, is always the name of the script you're running or the program you're running. So we want to start with argument 1 and just the rest of the arguments after the script name. We're going to say arg equals int of arg. So we're going to convert it into an integer. And then we're going to say total equals total plus arg. And then once we've added up all of the parameters, we're going to just print the sum is total. Okay, I'll leave that up for a second. Any questions on anything I've talked about so far while I let everyone type this out? Okay, does anyone need more time? Okay, so I'm going to push Control O, write this out as sum.py, enter. And I'm going to push Control X to get out of here. Now I can see the Docker file here and the sum.py file. And I just want to test my sum.py. I'm going to say Python sum.py 1, 2, 3, 4. Oh. Try turning on Conda and then run it. Okay, so hopefully you all are able to run your Python sum.py, but if you can't run it because you don't have Python installed or something, that'll be okay because we can install Python inside of the Docker image. But if you run it and you get an error, that's probably because of a typo in the code. And if anyone needs me to put the code back up, just let me know. Okay, I'm going to assume we're okay to move on then. Okay, so now let's open up the Docker file. So obviously the sum.py file that we just made is very simple. It's going to run on pretty much anyone's computer, whatever version of Python they have installed. That's, you know, if I had more time, I'd write a really complicated program that we could all use that wouldn't work on anyone's computer. But this sum.py is just kind of a placeholder for whatever complicated piece of scientific software you're going to be writing someday. So what we want to do is we start with, you know, whatever operating system we're going to use, in this case from Alpine. At some point in the future, you may be embedding software that you need to embed in Ubuntu, or you may need to start, you may want to start with a slightly more advanced Docker image like the SciPy and NumPy Docker image that they publish. I'll talk about that a little bit more once we finish this example. But regardless, we're going to start with some Docker image with the operating system and everything installed for us. We're going to set up the Docker image to have all of the things we need installed inside of it. So in this case, we just need Python installed. We don't need to install NumPy or anything like that, but you could imagine that we might, you know, in theory, in another image, we might now want to run, you know, pip install NumPy or something like that. Don't put this up there. It won't work if you include that. Alpine cannot install NumPy. It's not an advanced enough distribution.
Is it possible to have comments in this image?
Yes. In fact, that's here. I'll just show you. If you just put hashtags, those are comments.
Cool. Thank you.
Okay. But you might imagine that you might want to install a bunch of stuff. You might want to download files from the web. You might want to put all kinds of stuff inside of your Docker. And in particular, you might have written some code that you want to put inside the Docker image. So we, just like we did with this sum.py file. And to do that, we use the copy command. Now the copy command is only allowed to access things in the directory with the Docker file and below. You cannot look up the file system when trying to copy things in. And that's a security issue because Docker always runs with root access. They don't want you mucking around with things that aren't in your current directory. Regardless, this mostly is not an issue. We're just going to say copy sum.py to /sum.py. So what this is the path on my local computer of sum.py. So there's a sum. In fact, I'm going to rename this just so it's a little bit clearer. Sum.py here is the path on my local computer in the current directory with the Docker file. We're going to copy it to the file sum inside image.py inside of the Docker image. Does that make sense? Did I make that more confusing? Okay. All right, so once we've copied that in, we now may want to change the command here. So rather than running sh, we're going to run python sum inside image.py. Now, I believe that this is not actually going to work, but I'm just going to check my notes. Yeah, okay, so this looks like an intuitive way that we would want to write the command, but it's not the way that Docker expects you to write it. Instead, it expects you to give it sort of like a list, like a Python list of strings. So the first thing we'll do is we'll say Python, like that. Now, the reason for passing the command this way instead of just as a single line is essentially a historical thing about Unix and POSIX operating systems. Whenever a command is run, under the hood somewhere, there's a list of strings, each of which is an argument to the command that gets passed into the command. That's kind of why we did the sys.argv. We looped over sys.argv in that script, is because command line arguments to commands always come as a list of strings. That's just how operating systems do it under the hood. And so this command is kind of imitating that. You're supposed to pass it a list of strings. This makes it, one advantage of this is it makes it easier to have arg with spaces like that if you wanted to have an argument with spaces in it. But honestly, for the most part, I find it more confusing more often at the time, most of the time. But regardless, that's how it's expected to be done. Okay. I'm going to go ahead and save this out as Docker file.
Sorry, can I ask another question?
Yeah, of course.
What is the difference between the run and the command prompts in there? Like when would I use run and when would I use command?
Yeah, so run is something that gets run during the building of the Docker image in the Docker file. So if it says run, that means while it's building the Docker image, after it's pulled the Alpine Docker, it's going to run this command inside the image. The command means that when someone else comes along and runs the Docker run command to take your image and make it into a container and have the virtual machine do whatever it does, the command is what gets run inside of the Docker container once you've started up the virtual machine. I realize that there are multiple uses of the word run here, which I think is a confusing thing that Docker didn't really think about when they designed this language. But that's essentially the two different uses here. This run inside of the Docker file means run this command during building of the image. And this command is what actually gets run when you run the Docker run command from the command line. Did that clear things up?
Kind of, thank you.
Yeah. Sorry, it's not clear, but that's just how it is. Okay, so I'm going to Control X to exit out of there. And now I'm going to once again say Docker build -t Alpine, and I'm going to call it Alpine sum this time. And then give it dot. for the current directory. And you can see that now you may have noticed that it was even faster this time. And the reason it's faster is because the last time when we built Alpine test, the first Docker image, it pulled Alpine and it ran the APK add Python command. And it remembered that. It knows that those have been run. And so when it opened up this new Docker file and saw the first 2 lines were the same as that last one it built, it says, oh, I don't need to repeat this. I've already done it. I'm just going to pull the relevant bits out of that other image and use it. So when you run the Docker build command, sometimes it can take a really long time to build Docker containers. But if you rerun it after you've gone through half of it and then it failed, it won't rerun that first half. It'll pick up with whatever it left off, as long as those commands in the Docker file haven't changed. Does that make sense? Okay. Okay, so now we can say Docker run, and we don't need to say -it because we really aren't going to interact with it. We're just going to tell it to sum up some numbers. So we can just say Docker run Alpine sum 10, 11, 12. Oh no, unknown, or sorry, path unknown.
I think it's Alpine test, right?
So I just built the last, I think I built it as Alpine sum here. Build. Well, let me try this. I have a couple theories as to what's going on. Let me try it with -it. No, okay. Let's see, create film. Ah, okay. I think what happened is that I think we maybe need to call this Python 3. I just want to make sure I didn't mistype anything. Save that and exit and try this again. So I'm going to rebuild it with the build command again. And then I'm going to Docker run some. No. Okay, let's try something different. Docker run -it Alpine sum sh. Okay, so the Docker container itself is okay. If I say Python 3 /sum inside image.py. So it works okay.
Are you supposed to tell it to expect arguments after?
I don't think I should have to do that. Let me just check my notes here. Actually, you're right. I misremembered how you use this command. Okay, so we're going to open up the Docker file again. Yeah, I totally forgot there are actually 2 different kinds of command. There is an entry point command, which basically what this says is when the Docker starts, where do you enter the computations? Where do you enter the Docker image? So this is actually where I want to put Python and some inside image. So okay, so then what is the command for? Command is a little different, and honestly is probably not a very good name for what this actually does. If you don't provide arguments to the Docker run command after the Docker image name, whatever is in the command list get provided as arguments. Since we didn't have an entry point, it didn't know what to do with the command. That was basically what it was telling us. So basically, we don't want these. We maybe don't want there to be any default arguments, in which case we could just comment that out and have it just have an entry point. But for kind of the sake of demonstration, let's go ahead and put some arguments here. Okay. Some inside image. Okay. So I'm going to go ahead and write this out. I need to leave it up for a minute. Go ahead and exit here. Okay, now I'm going to Docker build -t alpine sum dot. Once again, it builds it pretty quickly. And then we can Docker run alpine sum. And if we don't provide any arguments, it should add up 10, 11, and 12. And it does. The sum is 33. However, if we say Docker run alpine sum 1, 2, 3, 4, it should run for those arguments instead of the arguments we put in command. Okay. Does that make sense to everyone? Any questions on that? Yeah.
Can you repeat again what the difference is between entry point and command?
Yeah. So when I say Docker run alpine sum like this, when what it'll do is it'll take the Docker image or and turn it into a Docker container and start up the virtual machine, and then it needs to know what to do. So once it started the virtual machine, it goes and finds the entry point, and whatever command is in the entry point, it runs that command. The cmd, the command, that's a list of default arguments. So if we run alpine sum like this, then the command that gets run inside of the Docker container when it starts is the entry point plus the command as arguments. I know that's really unintuitive, but it's whatever command you have in the entry point is the base command, and then the arguments in the cmd list get appended onto the end of the argument list. Alternatively, if we provided arguments like 1, 2, 3, 4, then it takes the entry point command and it appends 1, 2, 3, 4 to the list instead of what we put in the cmd list. Okay, so it's really unintuitive, but that is basically what it does.
Maybe, sorry, do you know some use cases for that? Like why would we use command? Yeah, why would you use command? Is that your question also? Yeah, okay. Yeah, so it's pretty common that you want there to be some default behavior when you start up a Docker image. An example, I'll just use an example that I've done. So again, the Docker image that contains the NeuroPython library, when you start that image and turn it into a container, it starts up a fairly complicated virtual machine that has Jupyter installed inside of it, and it runs a startup script. And the startup script looks and sees whether you've provided the argument notebook or prompt or any of the NeuroPython commands. And if it sees that you've added notebook, it starts up a Jupyter server, and you can connect to it as a Jupyter server. The entry point is startup script.sh. It's the script that gets run. The command is notebook, and that means that if you just run Docker run NeuroPython, it starts up the startup script with the notebook command, and so it starts the notebook. But if you say Docker run NeuroPython, some other NeuroPython command, it'll run that command instead. So it's just a way of providing default arguments. That's really all it is. Yeah.
Are Docker files shared and like viewable when you have like a public Docker image?
Yeah, so the Docker file itself does not get saved as part of the Docker image, although I do believe Docker images contain sets of, like they have an internal representation of that. But I think the better answer to your question is if I go, for example, over to GitHub, and I'm just going to go to, since I've been talking about it, I'm going to go to NeuroPython, the library. You'll see that right here in this, right here is a Docker file for NeuroPython. Make this a little bigger. And if we click in here, you'll see that it's a more complicated Docker file than the one we're using, but it's got a bunch of run commands, a user command, which we haven't talked about and won't have time to talk about. It's got a copy here where it copies the whole NeuroPython library into the Docker image. It copies some extra information and changes permissions on some files, and eventually it says it's going to run this startup script, which is called main.sh. So this is an example of how these are usually shared. They're just part of the GitHub repository, and the idea is that you can go git pull Noah Benson NeuroPython, go into that directory and type docker build dot, and it'll build the NeuroPython Docker. without you needing to know anything about my configuration or operating system or anything. Yeah, good question though. Yeah.
I'll be dipping ahead a bit here, but if you say you can run the Jupyter Hub inside this Docker, does it then run inside of your container?
Great question. All right, so I do want to answer that, and we'll go to it next. I just want to make sure there aren't other questions on what we just ran before I jump into that. Okay, great. So often you need to have your Docker container interact with the rest of your computer somehow. So a great example is the fMRI prep Docker, which needs to have the data from your subject. Like it needs to have your fMRI data in order to be able to run it. And obviously, it would be a real pain if you had to go edit their Docker file and add a copy line in order to copy your subject inside of the Docker before it got built. That's not how you do it. Instead, there are various command line options to this Docker run command that let you tell it ways that it can interact with your computer. So we'll start with probably the most common one, and one of them is just port. So if you know what a port is, basically Jupyter runs on a particular port, like 8000 usually, I think. And ports, when you connect across TCP/IP standard protocols, you connect not just to a website, but to a port. So like when you connect to an SSH, if you connect over SSH, you're always connecting to port 22. That's just the standard number for SSH. For HTTP, not HTTPS, but old-fashioned HTTP, it's always port 80. These are just kind of, ports are just numbers that are assigned to particular kinds of internet services. And Jupyter runs on port 8000. It's just the number it uses. So when you connect to a Jupyter Hub instance on your local computer, you connect to your local computer port 8000. And that's how you find Jupyter Hub or Jupyter. If you run Jupyter inside of a Docker image, then inside the virtual machine, port 8000 is open, listening for connections. And if you connect to that port inside the Docker container, you would connect to Jupyter. But port 8000 on your computer is not listening, because that's only listening inside the Docker container. So you have to tell Docker, hey, I need you to open up port 8000 on the local computer and forward it into the Docker. And to do that, you would just do Docker run, I believe it's -- port 8000:8000, saying 8000 on my local machine, forward it to 8000 on the inside of the Docker container. And then you would run it. Yeah, there's a tool called Docker Compose that we're just not going to have time to talk about, unfortunately. Docker Compose is used to make some of these kinds of commands easier to use. So if we were to go back to the NeuroPython example, the Docker file says nothing about ports. But if we went to the Docker Compose file here, you notice that there's an entry for ports that says, in this case, port 8888 to 888 inside. Anyway, there's information about Docker Compose inside of the lesson. We're not going to talk about it really anymore today, I don't think. But it's a really handy tool for some of this kind of stuff as well. Okay, other questions? All right, so okay, so that's ports. I said I was going to do ports second, but I guess not. So we'll talk about file systems now, or volumes, which are a more important thing. So again, going back to the example of fMRI prep, where you need to provide the fMRI prep Docker container with all of your MRI data. So we'll do this in a slightly different way. We're going to use Nano to edit this Docker file again. Now in this Docker file, we use this copy command to get sum.py inside of the Docker container. And that works just fine. That means that if we were to, we could, for example, do a Docker copy command to get that sum inside Docker or sum inside image.py and copy it to our local computer. There's good reasons to do that sometimes. And in general, if you have code, you typically put the code inside the Docker image with a copy command. But in order to demonstrate this other principle, let's suppose we didn't do that. And we actually expect the user to provide the sum.py file as part of this. So like, this is no longer a Docker that does sum.py. It's going to be a Docker that runs a script called sum.py. And what we're going to do is we're going to have this sum.py be in /mount/sum.py like this. So notice that I commented out this copy line so that we no longer have the sum.py inside the Docker container or the Docker image. And I came down here and I changed the entry point to say Python /mount/sum.py. The /mount directory on Unix Linux is typically used for external drives or network drives. So like if you're going to mount your Google Drive, you would probably make a directory in /mount/Google or something like that. And then the file system would do what's called mounting, where they take that external drive and they represent it as part of your file system. On Windows, you would have like a different drive letter for it typically, but in Unix or Linux, this is how you do that. So the reason I'm putting this in mount here is because there is no, I mean, we don't have a sum.py inside of this Docker when we build this, since we've commented this out. But we're going to take our local directory and mount it inside of the Docker container when we run it, so that sum.py will be there for us. Okay. If that doesn't make sense yet, hopefully it will in a second. I'm going to push Control O to write this out, and Control X to exit. All right. So again, we have our Docker file and our sum.py. I'm going to do another Docker build -t alpine sum doct. Okay. So now if I just say Docker run alpine sum, and I don't provide any arguments, it's going to try to run Python /mount/sum.py, and it's not going to find the file. Can't open file /mount/sum.py. So that file's not there. However, we can say Docker run, and then we can give it the -v option for volume. And we can say dot being our current directory /mount. What this is saying is take our current directory, which has the Docker file and the sum.py in it, and mirror it to be /mount inside of the Docker image, or the Docker container. And then I can say alpine sum. And then I can provide, 1, 2, 3 as arguments. It's too short. I think it actually may want a full path now that I think about it. So I think you may need to put $PWD here. This also, I think, is a security thing. It doesn't like it when you use relative paths. It wants to know exactly where things are coming from. So I think if we run it like that, it works just fine. So in case you haven't seen it, $PWD is always just your current directory. So that's what that inserted there. That makes sense to everyone? Now, I want to demonstrate one more thing about this. Let's go ahead and open up our Docker file again. Actually, I don't think we do want to open up the Docker file. Let's do this a little differently. We're going to open up the sum.py. And oh boy, I hope I can do this without a reference. But what we're going to do is we're going to have it open up an output file and write the output to the file. And the point here is to show that you can edit when you mount a directory inside of your Docker container. You should be able to edit the files inside of that directory. So we'll say with open result.txt. And in fact, we'll make this /mount/result.txt as an absolute path, because this is going to run inside of the Docker image. So we can use /mount/result.txt. We're going to open it in write in text mode. So if you're not familiar with Python file, low-level Python file operations, this is basically just how you open up a file, this particular file, so that you can write into it. And we're going to call it file here. And then we're going to have this print line here, just like it is, except we're going to pass it one more argument, which I believe is file equals file. Does anyone know that I'm wrong here? No. Okay. We'll find out if I'm wrong in a minute. Okay. I'll leave this up for a second just so everyone can copy it. Okay. We'll go ahead and write that out. And then Control X to exit. Okay, so I'm going to Docker build -t alpine sum dot one more time. And then I'm going to say Docker run alpine sum. Whoops, I need to do Docker run -v $pwd:/mount alpine sum. Now, if I got the code right, and if this works, then it's not going to print any output. It's instead going to open a file in this directory, which we mounted inside the Docker, and write out the result. Okay. And now you can see that result.txt file. And it says the result is the sum is 33. 33 came from the fact that in our Docker file, we had the default arguments 11, 10, 11, and 12. Okay. Any questions about that? So this is basically how fmri prep works. And if you were to go look at the fmri prep instructions for running the Docker command is going to be something like docker run -it-v, and then a bunch of whatever your paths are that you mount inside of the Docker container. Traditionally, people have it mounted like /inputs for inputs, and then they have another directory /output for outputs. Yeah.
Is there a way to convert your Conda environment to a Docker container easily?
So that's a great question. Conda environments have the nice feature that you can always dump a Conda environment to an environment.yaml file. And then you can always take an environment.yaml file and create a new Conda environment from that environment.yaml file. That said, I have rarely used Conda in Docker because the point of Conda is to separate your different installations. So you have like a version of Python installed and a version of many libraries installed in one Conda environment. Inside of a Docker image, you've already got an isolated environment. So you really don't need Conda. You can just install Python and install the libraries you want in kind of the global namespace.
Yeah, I guess my question is like oftentimes I'll have a different Conda environment for each of my projects.
Yeah.
And if I want to create a Docker container to share,
Mhm.
I guess my question was whether I could, I guess maybe use the .ym mounted file to create a Docker container that I could then share. Useful process for that.
So I don't know that, I wouldn't be surprised at all if someone had written a script that did exactly what you're proposing there. I just don't know of it. What I'm pretty sure of is that Conda has published a Docker image that already has Conda installed. And in fact, this is actually the last thing I was going to kind of talk about today, is that if we go to, let's just look at Docker Hub. So go to hub.docker.com. And this wants us to sign up. Well, we don't have to sign up. So you can come up to this search box and let's just search for Conda. And right off the top, there's various Condas for different Python versions. So like here's what looks like Conda Linux 64-bit Linux Python 3.8. This is the name of the Docker image. And you'll notice there's the continuum.io, who's the people who maintain Conda, as the username / and then this Docker image name. This is just telling you what's installed inside the Docker. Basically, it's saying this Docker runs a 64-bit version of Linux and it's got Python 3.8 installed. But basically, you could use this Docker image as the from line in your Docker file, and it will start with this image, and then you can just run Conda commands as your run command. So that's kind of a really great feature of these Docker files. And in fact, I don't know if any of you noticed, but in the NeuroPython example that I showed you, the very first line was from Jupyter /SciPy notebook. So I didn't want to have to deal with installing Jupyter inside of a Docker image. That sounds really complicated. Instead, I just went and found the Docker image that already had Jupyter and SciPy and NumPy and everything installed, and I used that as the basis for the NeuroPython Docker. That makes it way easier for me to get everything working rather than trying to install it myself in the Docker file.
In terms of like workflow, when you're, I think you touched on this a little earlier, like when you're developing something that you're gonna share eventually, should you start in a Docker container and develop, or should you like get it working and then put it in a Docker container, or?
So yeah, that's a great question. My advice is, unless you have a reason to start in a Docker container, do whatever's easiest for you. Docker can make things more complicated, so it's easier to come to Docker when you kind of have things figured out yourself. If you've got some reason to start in a Docker container, for example, you're doing a project across groups and you just don't have similar environments, and you know that you're going to need to do everything inside of Docker images, that's a good reason to start with Docker images. But unless you've got a good reason, I would say do what you're comfortable with and move it into a Docker later. That's just my personal experience. I know a lot of people in the industry say that's the wrong way to do it. You should always start in Docker because that's the kind of standard and everyone can run it. But I find that to be very, very difficult to start in Docker. So yeah, I'd come back to it later. Was there a question in the back? No. Okay. All right, we've actually gotten through as much as I expected us to get through today. And honestly, we're already a little over the typical time, so I'm just going to say we'll call it here. I do want to point out that the lesson plan that I gave you the link for, and also the link is in Slack, does include another section that we didn't get to on Docker Compose. Docker Compose is just real quick is a tool for automating both the building and the running of containers. So a lot of times when you distribute a Docker file, you really want people to build it and then run it with a particular set of commands or of options. And Docker Compose lets you kind of put those into a file as well, so that when you distribute something like a library over here, again with NeuroPython, we have the Docker file to build the Docker image. And then there's also a Docker Compose file that says, okay, you always want to run it on this port with this port argument, and you always want to provide these environmental data, and you always want to do these kinds of volume mounts. It's a way to specify those kinds of things to automatically happen. But I don't think we can cover it in 4 minutes or whatever, so we'll stop here.